Today we are going to see about the KMP string matching algorithm. So KMP, it stands for Knuth, Morris and Pratt, the name of the developers. So this is also a prefix based algorithm wherein the characters are compared from left to right. So unlike the other suffix based method like Boyer-Moore algorithm or suffix tree, wherein the comparison of the string is going to take place from right to left, here in case of your KMP string matching algorithm, the comparison takes place from left to right, and hence it gets the name as the prefix string. So here we are going to make use of a variable called pi. So this is referred to as a prefix function. There is another name to this particular function. It is referred to as LPS. So what is LPS is the longest prefix which is also a suffix. So based on this LPS only we are going to perform the string matching algorithm. So the main drawback of using a naive based string matching algorithm is that in case of the other technique, we will be comparing the characters one by one. So if in case a string mismatch is going to occur, we are going to start from the beginning. So this is really going to be a time consuming operation. Whereas in case of your KMP algorithm, what we are actually going to do is we are not going to compare the characters one by one. If in case a mismatch is going to occur, we are not going to start from the beginning. Rather, we are going to skip those characters which are mismatching with each other, and finally moving on to the new set of characters, and repeatedly doing this until you are going to reach the end of the text. So thereby we can reduce the time complexity and the time taken for the number of comparisons to a greater extent. So we will be seeing in detail how to calculate the LPS. So assume like the word which I am going to consider is going to be onions. So onions is the word which I have to compare this against the text. So onions is going to be the pattern which is given to me, for which I need to calculate the LPS value. So we'll see how to calculate LPS. So first of all, the very first step for calculating the LPS is count how many characters are present in this particular input. So 1, 2, 3, 4, 5 and 6. So totally 6 characters are there, which means that my input array for the LPS is going to contain 6 characters. So how exactly am I going to solve this LPS is initially read from the first character. So the first character is 0 and I don't have any other characters to be compared. So when I am going to calculate the LPS array, so totally 6 characters, so the size of your LPS is also equal to 6. 1, 2, 3, 4, 5 and 6. So initially I have the character O. So this is iteration 1 where I have only one character called O, and since I don't have any other elements to be compared, so the LPS value of the first character is equal to 0. In the second iteration, take the first character and the second character. 2 characters I have to take it. So in the second iteration, ON I am going to consider. So I am going to see whether I'm going to have a proper LPS value for this particular input. So the second input is going to be on. So O is one character, N is one character. So only one character comparison I can make in over here. So I don't have any repeated character. So this is a different character and this is also a different character. So the LPS value for second iteration is also equal to 0. So we will move on to the third iteration. So third iteration I have to consider the first 3 characters O, N, I. So character by character I have to compare it. So first character with last character, first 2 character with last 2 characters. So if n value is equal to 3 characters are there, means 2 iterations I have to go. So first and last, first 2 and last 2. See whether any same characters or same set of substring is appearing. So O is different, I is different, ON is different, NI is different. Since I don't have anything in common, LPS of the third iteration is also equal to 0. So now I move on to the fourth iteration. So fourth iteration, in turn it means that I have to go for 4 characters, O, N, I, O. So 4 characters means maximum 3 substrings I can consider, not more than 3. So O is the first character, first and last character is one step. First 2 characters and last 2 characters. First 3 characters and last 3 characters. So not more than this, because the number of characters is equal to 4. Only the substring I am going to consider, substring with length 1, length 2 and length 3 respectively. So O and O I am going to compare. Yes, it is the same. Count the length of the same thing. So here O is going to be the prefix and O is going to be the suffix. So this is a prefix which is also a suffix, and hence it gets the name as longest prefix, which is also a suffix. So O is acting as a prefix and O is also acting as a suffix for this particular set of string called ONIO. For this particular string, O is the prefix and O is the suffix, right? So the maximum length is going to be 1, and I don't have any repeated characters or any overlapping thing hereafter. So in the fourth iteration, my value is equal to 1. It means that there is one prefix which is also a suffix, and the length of that particular character is equal to 1. So we have to continue this till 6th iteration, because the length of this particular string is going to be 6. So in iteration 5, obviously I need to consider 5 characters. The first 5 characters, O, N, I, O, N, onion. Onion is the thing which I am going to take in. So as usual, you have to construct substring with character of 1 length, 2, 3, maximum 4. So maximum 4 only I can consider, because the total length of the string itself is equal to 5. So one character means first character and last character, prefix and suffix. Parallelly I am going to compare. First 2 characters and last 2 characters. First 3 characters, last 3 characters. First 4 characters and last 4 characters. So maximum I can go till this. So length parallelly I have to calculate. So what about the length value? Initially O and N, it is different, so this is 0. ON and ON, yes, prefix and suffix both are the same. And what about the length of that particular substring? The length of that particular substring is equal to 2. And next I have ONI and ION. So I don't have any overlapping prefix or the suffix, so that is equal to 0. And 4 characters, that also I don't have anything in common, so that is also equal to 0. So the only valid value which is over here is going to be 2. So the output of your 5th iteration is going to be 2. And finally, for the last iteration, I have to consider all 6 characters, O, N, I, O, N, S, onions. So I have to iterate it one by one. Substring of length 1, length 2, length 3, length 4 and length 5, because maximum length itself is 6. So substring means maximum 5 I can go. So first character, last character. First 2 characters, last 2 characters. First 3 characters, last 3 characters. First 4 characters, last 4 characters. First 5 characters and last 5 characters. And if you consider the length of this particular iteration, I don't have any overlapping prefix or suffix, so this is equal to 0. Nothing in this thing also, no common thing, no common. Even though I may have common characters, the entire substring should be same, like similar to this on and on. So the substring itself should be same for me, so I don't have anything in common. So the end of the iteration, my value is equal to 0. So this is how the LPS of this particular pattern onions is going to look like. So maybe I can take another one example to calculate the LPS. So assume like I'm going to consider the pattern A B A B A C A. So first step is count the number of characters 1 2 3 4 5 6 and 7, which means that 7 iterations I have to go. So the obviously the size of the LPS array is also equal to 7. 1 2 3 4 5 6 and 7. So start with iteration 1. Iteration 1 contains only one character, that too the first character A. Since I don't have anything to be compared, the value is equal to 0. In iteration 2, first two characters I have to take it. So A and B will be compared. Two characters means maximum single character comparison I will be going for a substring. So since prefix and suffix is not the same, this is also equal to 0. In iteration 3, first 3 characters I am going to take in. 3 characters means you can go for substring till length 2. So A and A, AB and BA. We cannot go beyond this because maximum substring length is equal to 2. So now coming to the length of this particular prefix and suffix. Yes, prefix is A and suffix is also A, and length of this thing is equal to 1. Here prefix is AB but suffix is BA. Even though the character is going to be the same, the substring is not the same. Right, so which means that the length is equal to 0. So the maximum among all these things you have to take it. So the maximum value is equal to 1. So the output of the third iteration is equal to 1. And next we have iteration 4. For iteration 4 I have to consider the first 4 characters AB and AB. So start from the beginning. Single character comparison, double character comparison and 3 character comparison. So coming to the length part, prefix is not the same, so 0. Yes, here prefix and suffix is going to be the same, and this is going to have a length as 2. Here I don't have any common prefix or suffix, so this is equal to 0. So the output of the iteration number 4 is equal to 2. So parallelly I am going to update this array. So I have to go for another iteration called iteration 5. So first 5 characters A, B, A, B, A I am going to consider. So single character first and last, double character first 2 and last 2, 3 characters first 3 and last 3, 4 characters first 4 and last 4. So not more than this because the maximum length itself is equal to 5. So coming to the length, yes, I have overlapping character, so same prefix, same suffix, and this is of length 1. So here 2 character length I don't have any prefix or suffix in common, so this is equal to 0. Yes, comparing to the 3 character substring, I have ABA and ABA, which means that prefix and suffix both are going to be the same. So the length of this particular thing is equal to 3. And finally, for AB, AB and BA, BA, characters are the same, but prefix and suffix is not the same, so this is equal to 0. So if you have more than one valid value, always pick the maximum value. So even though I have length 1 and length 3, so we are going to consider the longest prefix, which is also a suffix, which means that the maximum value only I have to take. So the maximum value is equal to 3. So the output of the fifth iteration is equal to 3. So we are going to move on to the sixth iteration, wherein I am going to consider the first 6 values AB, AB, AC. So compare first character and last character, first 2 character and last 2 character, first 3 character and last 3 character, first 4 characters AB, first 4 characters and last 4 characters, first 5 characters and last 5 characters. So not more than this because the maximum length itself is equal to 6. So coming to the length, I don't have anything in common for first character, second one, third one, fourth one and fifth one. So even though ABA is overlapping, the last character is different for me, which means that the prefix and suffix is not going to be the same. So the output of sixth iteration is equal to 0. And finally, for iteration number 7, you are going to consider all the 7 characters at the same time. So single character, double character, 3 characters, 4 characters, 5 characters, and finally 6 characters. So sixth character, I'll write it over here. A, B, A, B, A, B, A, B, B, A, C, A. So if you consider the length, I have a common overlapping character over here, and this is of length 1. All other things, this is equal to 0 because I have nothing in common. So for the end of the iteration, 1 alone I am going to consider it. So this is how the final LPS array for this pattern is going to look like. So now we will see, provided we understand the basics of this LPS, so we will see how exactly KMP algorithm can be solved by making use of the concept of this LPS. So I will take a very simple example. So assume like the text which is given to me is AB, 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 ABC, ABC, ABA, BA, BD, and the pattern which is given to me is AB, AB, D. So this I have to check whether this particular pattern is present in this particular given text by making use of the KMP algorithm. So the very first step is for the pattern calculate LPS. So even though I have 2 inputs, only for the pattern you have to calculate the LPS. So AB D is the pattern, which means that the corresponding LPS array will be of size 5, since 5 characters are there. Similar to the previous slide, I have calculated the LPS, and I have already calculated the LPS, and I have updated the values here. So this is going to be the LPS part. So now what I'm going to do is, once you are done with the calculation, so the first iteration I'm going to write the full text as such. So what is the text? AB, ABC, ABC, ABA, BA, BD. So this is the input which is given to me. And what about the pattern? So the pattern which is given to me is AB, D. So character by character I am going to do a comparison, and I am going to check whether mismatch is there or a match is there. So first character, it is a match, second character is also a match, third is a match, fourth is a match, whereas I am getting a contradiction in the fifth character. What it means over here is, this particular pattern, whatever was given to me, is not matching with the first set of input. So which means that I have to check for the remaining input. So what usually will happen in a naive string matching technique is that I will be skipping the first character alone, and I'll start comparing from the second character onwards. But if you look into this particular example, even though the first 4 characters are matching, I am getting a mismatch only in the fifth character. So if it is a naive technique, I need to do 4 more computations or 4 more comparison to say that this is not a match for me. Whereas in case of your KMP algorithm, what we are going to do is, we are going to skip the characters partially. So how exactly are we going to skip the characters is just count how many characters are matching in the pattern. So first 4 characters are matching. So I have to calculate what is LPS of the index 4. So this is index 1, index 2, index 3, index 4 and index 5. Calculate what is LPS of 4. Why 4 it is? Because 4 characters are matching, 5th character alone is a mismatch for me. So that's why I wrote it as LPS of 4. LPS of 4 is equal to 2. So what I am going to do now is, so LPS of 4 is equal to 2. I am going to take these two numbers alone. So 4 minus 2 is equal to 2. In turn it means that shift 2 characters. So that is what it means. Why it is 4 minus 2? The index is 4 and the corresponding LPS value is equal to 2 for this index number 4. So 4 minus 2 is equal to 2. So shift 2 characters. Which 2 characters I have to shift? The first 2 characters you need not compare it again. Start comparing from the third character onwards. So in iteration number 2, don't use the first 2 characters. Skip those 2 values because 4 minus 2 is equal to 2. Skip those 2 characters. A, B, C, A, B, C, A, B, A, B, A, B, D. Removing the first 2 characters, this is what I am going to get it. Now coming to the pattern. Pattern I am not going to shift anything because that itself is going to be the input for me. So again you start from the beginning. Compare character by character. It is a match. It is a match. Third character, it is a mismatch. So now coming to the LPS part. So LPS of number of matches I have to consider. So I have 2 matches over here. So this is LPS of 2. What is LPS of 2? LPS of 2 from this array, it is equal to 0. So take these two numbers, subtract it. 2 minus 0 is equal to 2. Again shift 2 characters. So shift 2 characters means these two values I have to skip it. I have to start writing from CAB. So that is iteration 3. So continue this until you are going to reach the end of the string where no more comparison is possible. So skipping these first 2 characters. So the remaining characters are C, A, B, C, A, B, A, B, A, B, D. And the corresponding pattern is A, B, A, B, D. So now what will happen here? Start comparing character by character. So I don't have a match in the very first iteration itself. So if you don't have any common characters, it means that shift 1 character. So if the first character itself is going to be a mismatch, means directly you can follow the naive approach wherein you have to shift only the first character. So in iteration number 4, I have to skip the first character only. So start writing it from ABC, ABC, ABA, BA, BD, and the corresponding pattern is AB, AB, D. Now again you continue. Start comparing. First character is same, second character is same, third character is a mismatch. Since 2 characters are matching, I have to calculate LPS of 2. LPS of 2 is equal to 0. So 2 minus 2 is equal to 2. So I have to shift 2 characters. So first 2 characters I have to skip. Start comparing from the next half. So in iteration number 5, I will start with C. C, A, B, A, B, A, B, D. And the corresponding pattern is A, B, A, B, D. So again first character itself is a mismatch. So what I have to do, I have to shift 1 character, the naive approach. So in iteration number 6, so I have to skip the first character. So start from A, B, A, B, A, B, D. So next pattern is ABA, ABD. So first character is a match, second is a match, third is a match, fourth is a match, fifth is a mismatch. So four common characters I have. So LPS of 4. LPS of 4 is equal to 2. So 4 minus 2 is equal to 2. So again 2 character shifting I have to do. So 2 character means first 2 characters I have to skip it. So the last combination which I have to check is ABABD. So I'll move on to a new slide. So this is iteration number 7. So the text is ABABD and the pattern is ABABD. So the text is same, pattern is also the same. So what we are going to do, again do the comparison one by one. So match, a match, a match, a match and a match. So since all the characters are matching with each other, which means that this pattern is present in this particular text. So that's all. This is KMP string matching algorithm.